Hello and welcome again to another STEM video. This week we are going beyond the Milky Way. Now, the universe is a sprawling cosmopolis we call our home, our universe city. Our neighborhood is our solar system, which is a part of a suburb in our local galaxy, which is called the Milky Way. No one knows exactly how big the universe is, but some of the furthest distances measured are two pulsating stars called Cepheids, which are more than 65 billion light years from Earth. Now, light travels about 6 trillion miles every year. The current theory of how the universe came into being is that somewhere between 10 and 20 billion years ago, a huge explosion occurred that caused the universe to expand and suddenly projecting matter outward from the center. This theory, called the Big Bang Theory, was first proposed in 1927 by Georges Lemaitre, a Belgian priest and scientist. He based his theory on spectroscopic observations of the red shift of a distant nebulae in the universe. 2 years later, Edwin Hubble confirmed and expanded on these observations. Now, galaxies are clusters of billions of stars, nebulae, planets, and other objects held together by gravity. As you can see behind me, I have an image of the galaxy M31, also known as the Andromeda Galaxy. Now, they can range in size from 1,000 light years across to 1,000,000 light years across. Some are shaped like spirals, others are elliptical, while others are called irregular or peculiar because they have no definite shape. Scientists are discovering that black holes form the center of many, if not most, galaxies, including our own Milky Way. Now, our galaxy, the Milky Way, is spiral in shape and it contains more than 100 billion stars, and it's about 90,000 to 100,000 light years across. Okay. Our solar system is comfortably situated in one of those arms of the spiral where the neighborhood is a little less crowded, about 25,000 light years from the center. Galaxies contain clouds of dust and gas known as nebulae. Nebulae give birth to stars as the dust and gases are pulled closer and closer together by gravity until they start to spin. Now, behind me I have some various images of nebulae. Here we have the Orion Nebulae, the Horsehead Nebulae, and right here off to the side is the Butterfly Nebulae. Now you can see that the Butterfly Nebulae is named because of its wing shapes. As the atoms are compressed, heat energy is generated until the gas cloud gets so hot that nuclear fusion of the hydrogen atoms take place and the clouds begin to glow, forming a protostar. When a protostar stops growing, it becomes a full-fledged star. Stars may live for millions or even billions of years, but they do not last forever. When the fuel of a smaller star, like our sun, begins to be used up, it starts to shrink and it becomes a white dwarf. When all the fuel is used, it does not shine any longer, it becomes a black dwarf. Now, larger stars have a different fate. They burn hotter and brighter for a longer time. Eventually, nuclear fusion causes iron to form in the star. The iron absorbs energy, making the star a ticking time bomb that eventually explodes and becomes a supernova. Depending on its size, it then becomes either a neutron star or a black hole. The largest stars become black holes after they explode, collapsing under the pressure of tremendous gravity created by the massive object. Now, a black hole gets its name because of its gravitational pull is so powerful that not even light can escape it. The two main types of black holes are stellar and supermassive. Stellar black holes are formed when massive stars use up all of their fuel and die, collapsing inward due to the pull of their own gravity. Now, a supermassive black hole has been detected at the center of many galaxies. We think that massive gravity at the core of the galaxy, where stars are closely packed together, causes the black hole to form. The reverse could also be true. The black hole causes the star to become closely packed as they approach the event horizon of the black hole. With the right instruments and equipment, black holes are proving to be fairly easy to detect because as objects fall towards the black hole, they get very hot and glow brilliantly. What we see is actually the luminous gas cloud that surrounds the event horizon of the black hole, the donut-shaped zone of no return. Any objects that come within the event horizon is sure to be pulled into the black hole. Now, when students first hear about a black hole through movies or video games or science fiction, they may be concerned that they could be pulled into a black hole. Even if our sun were able to become a black hole, which is impossible because it is not massive enough, the black hole only has the gravitational pull equal to the object that created it. So it would exert no greater pull on Earth than the sun does. Now, as far as the supermassive black holes are concerned, one news report proclaimed that one was supposed to be headed our way, but it missed us by 1,000 light years. If you multiply 9.5 trillion kilometers, which is the distance light travels in a year, by 1,000, you would get a better idea of how far away that black hole really is. This is another celestial object in the universe called a quasar. A quasar is a massive object larger than our solar system that gives off huge amounts of energy and resides in galaxies that have black holes. When we look at a quasar, we are essentially looking billions of years into the past. Now, for dark matter. Matter is usually something we can see or touch. It takes up space and it has mass. So-called dark matter is one of the greatest mysteries in our universe because it cannot be seen. We only know it's there because it exerts a gravitational effect on objects nearby. Scientists think that more than 90% of the matter in the universe is dark matter, which is significant in understanding the origins and destiny of our universe. The amount of matter the universe contains affects how much gravity it has. And the more matter, the more gravity to counteract the forces of expansion. Now, engineers are helping scientists investigate black holes, galaxy formation, and the evolution of the universe, the recycling of matter and energy, and the nature of dark matter. And that's the end of our lesson today. Thank you for watching, and be sure to like and subscribe to our YouTube channel, and check out Miss Amy's Storytime and Spanish with Miss Marisol. Thank you. Have a great day.